Hello everyone. So in this video, we'll talk about another math counts problem. So this was a target question. So we have like a person, Lisa, wants to use a calculator to square a two-digit number. Okay, so just keep this in mind. But she accidentally enters the tens digit incorrectly. And when she does the new number, the result is 2340, larger than the original number that we were expecting. So basically, let's say like her number is AB, but she's doing instead like maybe changing this A to something else. Instead of doing this, she's using maybe CB. Okay, and then this is the new number that she's like putting into calculator instead of AB. And we are gonna square this, so we are squaring a two-digit number. So she is gonna have CB squared minus AB squared, and then this is equal to 2340 because we are going to get 2,340 larger than what's supposed to be getting. So CB is the new number, AB is the previous number, so that should be the difference of the square should be this. Like you can try taking the difference of square of this, but if I do so, I don't really get anything from there, so which is why I don't want to take the difference of square. But before we expand this, we have three variables with one equation, which doesn't make any like obvious solution. So for that reason, I'll just use the value of each digit. So if you kind of don't know, but let's just remember something as a kind of background. So like if I have, let's say 27, like two-digit number, I can write this as 2 times 10 plus 7. That is just the 27. If I have 41, I can write 4 times 10 plus 1. So instead of writing like the 27 as two-digit number, we can write as the place value of each digit. So same idea for CB, I can use the same logic to replace their values. So instead of CB, which is CB is two-digit number, then I can write 10 times C plus B, and then this is gonna be a square minus, and then instead of AB, which is AB is a two-digit number, so I can write 10 times A and plus B. And we will square this as well. So 2340, okay? This is something, but at the same time, it doesn't really give us anything either because we have some like expression to the second, some expression to the second power and stuff. Maybe we can expand this a bit. And I'm gonna remind the square of binomial at this point. So like if you have something, maybe I should use different variable. Like if I have, again, this is also a background that we need for this question. So if you have two terms, x and y, add up together, if you square them, so you can go ahead and write this x plus y 2 times and multiply, but we have a nice relation, that's identity we call, is this one, that's called square of binomial. And we can just apply this in our problem. Okay, if you don't know, you can just go ahead and write the BC plus B and twice and multiply, which will be the same thing. But this was like, I mean, this is 10C, not BC. So that was 10C. If you square, this is kind of our A, X in this case. If you square this, you will get 10 squared is 100. And then C squared will be C squared. Plus, you are going to multiply X and Y and double it. So the first term and the second term will be multiply and double that product. So 10C times B is 10BC, double, you will get 20 times B times C. Plus, you are going to square the second term, which is B squared. Okay, it's getting a bit messy, but it will be clear soon, I guess. So if you do the same thing, so you will get 100 A squared, 100 times A squared, plus 20 AB plus B squared. And then this is equal to 23, 4. I'm going to write times 10 because I do need some sort of prime factorization. So let's get started. So if you expand the second parenthesis with this negative, so you will get 100A squared, and then this is 100C squared. So I can pull that 100 as a common factor. So that should give us 100C squared minus a squared. Okay, and then that's 20b times c, and then if you expand this, you will get minus 20ab. So I can pull 20 as a factor, so that will give us b times c minus a times b. Okay, and then you got b squared, and then this is minus, this will be minus b squared, those will be gone. And then if I divide this by 2, you get 117, so that should give me 117 times 2 times 10, which is 2 times 2 times 5. So I'll just write 2 squared and 5. So since we have both sides, you know, this is like 100, this is 20, and then I do have like 5 times 4, that's also 20. I can divide everything, every like product by 20 to simplify. If I divide this by 20, so you will get just 5. So, and then instead of writing this, the c squared minus a squared, I will just use difference of squares. So we will get c squared minus a squared as c minus a, and then c plus a. And then this is called difference of square if you don't know, so that's also good to remember. I'll just add some additional videos about the square of binomial and difference of square if you are not familiar with those. And plus, so for this one, we know b, we have b, so we can pull that b as a factor. So if I pull, so you will get c minus a, which is helpful because we already have another c minus 1, a is right there. So, and then if I divide this by 20, so that will, like 4 and 5 will be gone, so you will get 117. So which is way better than what we have. So what we did basically in this step, we just divide both sides by 20 to simplify a bit. So as our next step, since we have c minus a and c minus a common expression, so I will take that as a factor. So if I pull them, and I have a bit more expressions, so I'm going to just use a bracket. And then when I pull this as a factor, so you will get 5 left, and then times c plus a, and then plus b. And then I will close parentheses because I pull this and this as a factor, so that should be this. And now this guy is like when you add the digit, that's 9, which means this is divisible by 9. So if I write 3 squared, and then 11 divided by 9 is 1, so you'll get 2, 7, 27 goes 3 times, so 13 times 9. Okay, so now let's pause a second and think about what's going on. So we have a product equals a number, right? But at the same time, we know that C, A, or B are just a digit. So digit can't be anything larger than 9. So, and C minus A could be like 9 minus like 1 at most, which is 8, because I can have A as 1 all the way to the 9. So the difference between C and A could be at most 8. And it could be lesser than, but at most 8. And we do multiply this by something to get this one. But at the same time, c minus a has to be whole, like some integer. So if you look at this guy, we have 3 squared and 13. So one of the divisors, which is c minus a, has to be one of the divisors of this guy in order for us to get a whole number. And then this is 5 times c plus a. C plus a will be larger than c minus a. And then you multiply that by 5, which means this factor should be way bigger than this factor. So, and also c minus a can't be larger than 8. So if you look at these options, you have only 2 options for c minus a. So you could have 1 or 3. If this is 1, so that the whole thing will be 117, which is 3 squared times 13. If this is 3, so you will get 3 times 13, which is 39. So you have 2 options. You can try maybe negative c minus a to see if this is possible, but you make sure that CB is larger than AB. If that's the case, C is larger than A. So which is, we cannot have negative values, even though for this product it's okay, but for our question it is not. So we have only 2 cases to consider. If I take the first case, I will probably not get the answer, but for the sake of seeing if this is really the case, let's do that. If C minus A is 1, then the remaining part should be 117. So 5 times C plus A plus B has to be 117. But you know, this is a multiple of 5, so, and then this is added by B. So in order for us to get a multiple of 5, the last digit should be 0 or 5, but this is 17. I mean 7, so which means that B could be 2 at least, because if this is 2, you will get 115. But 5, if you multiply by something, you should get 115. If this was 2, and the only way that will happen if C plus A is 115 divided by 5, which is going to be 23. But C and A are 2 digits, so at most is 9, which is 23 is not possible. If you increase this by 5, so you could get 7, but that will just make this 22, which doesn't make that either. So which is why the first case doesn't really work. So we were able to see this is not possible. And then this is only one left. So if the C minus A is 3, then this product should be 39. So let's go with that. So 5 times C plus A plus B equals 39. So 5 times 7 is 35. So this has to be 4 in that case. If I make this like 6, that means this has to be 9. But that is not possible, because if you choose like C minus A as like 3 and then C plus A is 7, that's C like 2. When you add those to equation, you got 2C equals 10, C is 5. But if I choose like this is 6, which is 30, and then this could be the 9, it looks like it's also working. But here's the problem with that. So if I have C minus A as 3 and C plus A as 6, and then this is odd, this is even. When you add, the A's will be gone, so you will get 2 times C. So 2T has to be even number, but we cannot get even by adding odd and even. So which is why C will not be integer in this second case. So that's why this is the only case that will work out. So C plus A is 7. So that should be 7. And that will give us like 10. That will mean C is 5. So we got C as 5. If C is 5, C plus A is 7. So the A is 2. Or you could just say C minus A was 3. That's also 2. You can get it. And the question was asking the sum of the 2-digit number Lisa entered and the 2-digit number that she meant to enter. So we are looking for the sum of the AB. So the A is 2, right? And then B is like 4. And we have CB, so C was 5. And then B is just 4 again. If you add them, so you get 78. So this was slightly challenging, especially if you had no idea about the digit problem like this by using its place value. And also we used 2 other like background in this problem, difference of squared and square of binomial, to make it a bit like faster. Even with those, this was slightly longer for a like target problem. And I'll see you in the next video.